These days, it's nearly impossible to get children interested in learning about physics. They're just too busy doing other things, like playing stickball and kick the can. Take this young man, for example. Hello there, young man.
Hello, disembodied voice?
Do you like learning about physics?
Ew, no, physics is boring. I like playing stickball and kick the can.
I thought so. You see, he hates physics. Don't fear, however. There is an answer. Comic books. I know, you think comic books are immoral and promote homosexuality. Well, watch this. Hey, little boy.
Yeah,
Do you like reading comic books?
I sure do.
Of course you do. It's not like you're a dirty commie. Are you?
No.
Ha ha! That's swell. Now let's take Superman for an example. Everyone knows Superman can leap tall buildings in a single bound, but do you know why?
No.
It's because of physics, son. You see, Superman comes from Krypton, a planet with a greater gravity than Earth. He is stronger than human beings, and that allows him to do amazing things like leap tall buildings. Here we see him attempting to do just that, and thanks to Newton's third law of motion, that for every action there is an equal and opposite reaction, when he pushes against the ground pushes back against him, lifting him up, up, and away. Superman's jump teaches us about velocity too. Velocity is the speed and direction of an object. Because gravity is pulling him down at a rate of 32 feet per second, his speed decreases until he reaches the peak of his jump. And because we know he can jump nearly 660 feet, we can employ a little math to find out the velocity of his initial jump. Don't worry, this won't hurt a bit. Velocity squared is equal to 2 times gravity times height. The square root of 2 times 32 times 660 gives us an answer of 205 feet per second. That's about 140 miles per hour. I bet you can't jump that fast.
No, sir.
Now, wasn't that fun?
It sure was.
Would you like to learn more physics?
I suppose.
Sure you do. Next, we'll look at the Flash.
He's fast.
Yes, that's kind of his thing. In this issue, he has lost the use of his hands. Don't ask why. But crime doesn't stop in Central City, so the Flash is as quick at thinking as he is on his feet. He finds a pear tree and shakes them free, and in the next panel he is using what is called Bernoulli's principle, where the speed of a fluid increases, internal pressure increases.
Huh?
Don't worry about it. It just means that when the Flash moves really fast, he creates an area of high pressure next to the area of low pressure, which causes the pears to lift off the ground and follow him, like when Mom vacuums the house. At the last second, though, he stops and ducks right in front of the crook, and the pears continue forward, proving Newton's first law: objects at rest stay at rest, and objects in motion stay in motion, unless acted on by an outside force, which happens as they hit the crook square in the kisser. Which incidentally proves Newton's third law again, too. Whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first. Or to keep it simple, forces come in pairs. Get it?
Yeah.
Say, little boy, who's your favorite superhero?
Well, that's gotta be Spider-Man.
Great. I love Spider-Man too. Let's learn about impulse and change in momentum. You know Spidey's pretty gal pal Gwen Stacy, right, little boy?
I sure do. She's swell.
Yes, she is. Or at least she was. When the Green Goblin throws Gwen from the top of the George Washington Bridge, Spider-Man has to act fast to save her. And he does. But, uh-oh, notice the snap, little boy? That's right. When he pulls Gwen back up, she is dead. So what went so horribly wrong? Well, To save Gwen, Spider-Man needs to change her momentum before she reaches the water. The George Washington Bridge is 604 feet tall, and she's almost at the water. When it comes to momentum, the time it takes to change is inversely proportional to the force that is exerted. That means when one goes down, the other goes up, and vice versa. Spidey stops Gwen too fast. Her neck can't handle that force, and snap! Ha ha ha! Poor Gwen. Remember, kid, it wasn't the great fall that killed Gwen Stacy. It was the sudden stop at the end. So there you have it. With just a couple pages out of some funny books, we've taught this little ne'er-do-well Newton's first and third laws, Bernoulli's principle, and a little bit about velocity and impulse and momentum. That wasn't so hard, was it, little boy?
No.
Good. Say, little boy, I've got one last question to ask you. Why do you have a full beard?
From all the hormones in milk, of course.
Ugh. Sorry I asked.